You got a question? 71. How does a monoatomic ion form? They form by either gaining or losing one or more electrons. So they're atoms that gain or lose one or more electrons. If you'll think back to when we're doing orbital notation, and then, let's see, that was maybe unit 2, and then unit 3, we built ions from that by sticking electrons in the orbital notation or taking them out. Remember that? So it's adding on to the atom extra electrons or taking away from the atom some of the electrons it has. Okay? Yes, Carolyn?
Number 97, the balance that equation.
Sure. I should have left a little more space there. Okay, now the question on the practice test doesn't show the physical states for CO2 or water or oxygen. You just need to know that those physical states are going to be gases when it's a combustion reaction. What? It's a combustion reaction. Hydrocarbon and oxygen, you've got a combustion reaction.
Why is water?
Because of the heat. Think about burning anything. You got a lot of heat, right? So whenever you've got a lot of heat, then water basically it comes out as a steam or a gas. Okay? All right, so to balance the equation, then we need to write down the atoms here in our atom inventory. Okay, just put that in your personal file, and you've already signed in, right? Okay. All right, so how many carbons do we have on the left? 4. How many hydrogens do we have on the left?
10.
How many oxygens on the left? How many carbons on the right?
1.
How many hydrogens on the right?
2.
How many oxygens on the right?
3.
If you write it like a sneeze, chew, then on the right-hand side, you always get 1, 2, 3. Well, sorry. Try to make it easier. He doesn't like the fact that I call it chew. He wants to call it cho. That's fine.
Cho.
All right. So let's see if we can get it all to work out then. I've got to have 4 carbons on the right side, so remember you can only use coefficients to balance equations. The formulas are already balanced. We've got all the subscripts in there. Can't touch the formulas. Okay? Used to be a really famous song. Can't touch this. Okay? Y'all heard that, right? All right. Well, once the formulas are balanced, can't touch this. Okay? So I can only use coefficients then for those. So there's going to be 4 carbons, and I've changed the number of oxygens. So I've got 4 times 2, or 8 oxygens, plus the 1 here is 9. All right. So we're going to save oxygen for last. We want to balance hydrogen then. To get 10 hydrogens on this side, I need a coefficient of 5. That'll give me 10 hydrogens. It's going to change the number of oxygens though. 4 times 2 is 8. 5 times 1 is 5. So we have 13 oxygens. Everything's balanced except the oxygens, and we have a situation excuse me, where we've got an odd number of oxygens on one side and an even number on the other side. The simple way to solve it when you get to that point is to do what? Multiply everything by 2, but the coefficient here. Okay? So multiplying this 1, y'all see the 1 there, right? Because in your mind you should see the 1 there. Multiply that 1 by 2, you get a 2. Okay? This 4 by 2, you get 8. This 5 by 2, you get a 10. So we go back and recount everything in the atom inventory. So now we have 8 carbons, got 20 hydrogens. I didn't change the oxygens. On this side, I changed this to 8 carbons, 20 hydrogens, and 26 oxygens. Okay? Do I need to do the math to show you that? No, but I don't hear anybody saying yes. Okay? So all we need then is a number in front of this O2 that's going to give us 26 oxygens. The number we need is 13. 13 times 2 is 26. Okay? You got it.